Hi there, folks. Today we're looking at percents. And the thing about percents is percents are really just a ratio. And remember, a ratio is really just a fraction. So here it's a ratio expressed out of 100. In other words, it's a fraction where the denominator is 100. So if we see something like p%, that just means p over 100, all right? And one of the things that you want to start to think about is to make that connection between percents and fractions. Like if I talk about 100%, that's like 100 over 100, which is 1. So 100% is one whole. And so like when you think about 50%, that's 50 over 100, that's 1/2. 50% of something is half of something. 100% of something is one whole of something. And so making that connection between the percent and the fraction is very important. All right, we want to be able to think of these things a little bit more fluently than we have in the past, okay? For example, if I look at something like this guy, it just says to write 25% as a decimal. Well, if you understand that 25% literally means 25 out of 100, all right, it's a fraction, you just write it as 25 over 100. And now this is a job for your calculator. You do 25 divided by 100, it gives you 0.25. And if you don't know the trick for dividing by versions of 10 or multiples of 10, it's however many zeros there are, that's how you move the decimal place. So like here, if I started with a 25, it's like 25 with a decimal place here. 100 has 2 zeros, so you move it 2 places. And so it becomes 0.25. And we deal with that a lot when we start talking about scientific notation, which will be something that we deal with later. All right? If I look at this thing, again, 3% is 3 out of 100. That's what percent means. And if you divide those things, you get 0.03. All right. A lot of times in math, we will almost always, whenever we do equations or formulas, anytime a formula talks about a percent, that percent goes in as a decimal, okay? Because we can't plug a percent symbol into things, all right? The percent symbol literally means divided by 100, so that's how we plug it into equations. This guy, same kind of thing. 12.5% is 12.5 out of 100. That's what the percent symbol means. It means divide by 100. And when you do that, you get 0.125. Okay? I'm not putting boxes around these. And then this guy, it says write 0.82 as a percent. Well, this time we want to work backwards. And so this goes back to the same thing that we do when we solve equations. If I want to undo the process that I've been doing, I have to do the opposite operation. To go from a percent to a decimal, I divide by 100. So to get from a decimal to a percent, I do the opposite, which is multiply by 100. So here I do 0.82 times 100, and that gives me 82%. Again, hopefully you're looking at that going, okay, I can do a little bit of a shortcut there, Mr. Jansen, by just moving the decimal places. That's fine, and that's okay. All right, I'm going to continue to kind of show the work here. You feel free to do that shortcut if you can do it. So if I look at this one again, I want to go from decimal to percent. So percent means divide by 100. To undo that process, I have to do the opposite. So I multiply by 100. So again, it's that idea of doing the opposite, of working backwards. So I'm going to multiply by 100, and that gives me 36.5%. Again, same thing with this one, going from decimal to back to a percent. The percent was divided by 100, so if I want to undo that process, I have to do the opposite of dividing by 100, which is multiplying by 100. And when I do that, I get 2.4, and that's percent. All right, so that idea of doing the same thing that we've been doing with equations, doing the opposite to work backwards, okay? If I look at something like this guy, it says a student scored a 22 out of 30 on an assessment. What is the student's score as a percent? And so when we kind of think about this, this is almost like using our factor label stuff. Essentially what we're going to do is we're going to say, okay, well, it's presenting me with a ratio 22 out of 30. So 22 out of 30 is the ratio I want. But I need that to get a percentage. I need that to be out of 100. Well, the easiest way to do that is just go the route of making it a decimal first. So we're using the two things that we used up top here. So if I convert this to a decimal first, I just divide the 22 divided by 30. It gives me 0.73 repeating forever. So I'll just round it off and say 33. But now to go from a decimal to a percent, remember, to get a percent, I divide by 100. To get a decimal, I divide by 100. To get back to the percent, I have to multiply by 100. So I take this guy and I multiply by 100. I'm just doing the reverse. Okay. To get from a percent to a decimal, I divide by 100. To get from a decimal back to a percent, I do the opposite. I multiply by 100. So here I get 73.3%. Okay. And those are some hideous looking threes. I know I can do better. I believe in me. Even my percent sign wasn't great that time. Yeah, that looks like a 3. All right, I believe in you again, Mr. Jansen. But again, it gave me a ratio. I write the ratio as a decimal because it's easy to go from a decimal back to a percent. Okay? If we look at some of these guys, finding percentages of values, we're just going to write the percent as a decimal and then multiply. And again, that's the idea here. So if I look at something like this guy, it says find 25% of 80, and this time I will use the shortcut. So instead of doing 25% and changing it, doing 25 divided by 100, I'm going to go right to 25 divided by 100 is 0.25. So if I want 25% of something, essentially what I want is 0.25 of something. And the idea is to get a quarter of something, I just multiply it. So here, if I want 25% of 80, if I want 1/4, if I want 1/4 of 80, I multiply by 1/4. I multiply by 0.25. And so if I do that, the 80 times the 0.25, it gives me a 20. But that is the easiest way to find the percentage of something. I just multiply it by the decimal version of that thing. Okay? Same thing here. 62% is 62 over 100, which is 0.62. If I could write a 2, numbers are hard. So 62%, so 0.62, I multiply that by 120. And when I do 0.62 times the 120, that gives me a 74.4. And these are really easy to check. You can easily go back and say, hey, what is 20 divided by 80 to see if it gives you the 25%? What is 74.4 divided by 120 and see if it gives you the 62%? But again, to find the percentage of something, just like if I want to find the fraction of something, okay? Again, a percentage, a decimal, a fraction, they're all kind of the same thing. So if I wanted half of something, I multiply by 1/2. If I want 25% of something, I multiply by 25%, which is 0.25 as a decimal. If I want 62% of something, I multiply by 0.62. If I want 115% of something, I multiply by 1.15. And again, I get the 1.15 by doing 115 divided by 100. So if I want 115% of this, I multiply 1.15 times the 80. And that gives me 92. And you notice in this example, unlike the other examples, is I get a number that's bigger than the 80. And hopefully that makes sense if you really start to think about this. 25% is a fraction of 80, so it's smaller. 62% is a fraction of 120, so it's smaller. But 115%, because we're over 100%, remember 100% was the whole thing. So that's basically the whole thing plus an extra 15%, which is why it's bigger. Okay, and that's the idea. Any percentage under 100 is a fraction of that thing, so we get smaller values. Any percentage over 100 would be larger than the whole thing. Okay. If we look at something like this guy, it says 36 is 25% of what number? So we don't know. See, that of is telling us which thing is working with the ratio. Notice up top, it said 25% of 80, so I did 25% times 80. I don't know what that number is now, so I'll call it X. Anytime it says what number or what thing, all right, or what, we use a variable. So basically, I want 25% of something. I don't know what that something is. So 25%, that's 0.25. And then I multiply it by X this time. See, it's 25% of my unknown number, so of X. So I do 25% times whatever X happens to be. And is, that's like my equal sign. So anytime we're interpreting these things, when you see is, that's your equal sign. So is 36. And really, I could have literally interpreted it this way. I could have said, okay, 36 is, so equals 25% of what number? There's the x, okay? But notice here, we're doing the same thing that we did, but this time it's set up like an equation that we need to solve. And so right now I'm multiplying by 0.25. How do I undo multiplying by 0.25? Is that I have to divide each side by 0.25. Okay? But again, just setting up an equation and then solving that equation. So I get x equals, again, this is a job for my calculator, divided by the 0.25 is 144. And once again, it's really easy to check this thing. I can easily check this by going, okay, well, let's see. Let's see if 36 out of 144, see, because that's what I was finding. I was finding the whole thing. I had the piece. I needed to find the whole thing. If you do 36 divided by 144 on your calculator, you get 0.25. And isn't that 25%? Yeah, it sure is. Okay, so really easy to check these things. Okay? Let's talk about percent increase and decrease. We want to add or subtract the percent first and then multiply. All right. I'm going to do it twice here. The add or subtract the percent first and then multiply is the easiest way to do it, but it requires a little bit more thought. So let me show you how most of you would do it, and then I'll show you the alternative, which is what I'm describing here. So this is the alternative. You can do it the first way I'm going to show you. You can do it the other way by finding the percent and then adding it to the amount. All right, or subtracting it from the amount, depending on if it's an increase or a decrease. But I'll show you a slightly easier, slightly better way. For example, if we look at this one, it says a store marks up an $80 jacket 22%. And a markup is when they increase the price so they can make money. All right. Stores always mark things up because they buy it at one price, all right, from the manufacturer, and then they sell it to you at a larger price. They increase it by a percent so they can make money. That's what a markup is, okay? So that's an increase in price. So here's what we do. Most of you would probably go, okay, 22%. Well, to find 22% of 80, you do 0.22 times the 80, right? I take the percent as a decimal times the 80, so 0.22 times the 80 gives me a 17.6. And now that's not what they're going to sell the jacket for. That's the amount they're going to increase it by. So then what I have to do is I have to do the 80 plus the 17.6. And so I find out that the actual amount they're going to sell this jacket for is $97.60. And that is a perfectly acceptable way to do this. And notice it's two steps. I had to multiply by the percent to get the new value, and then I had to do some addition. I had to add that percentage on, okay? But now here's the interesting thing. Because we're working with percents, I could do it this way. Let's think about the whole price of the jacket. So $80 represents 100% of the value. Okay. And again, it goes back to that. If I think about percentages like fractions, 100% is one whole. Okay. It's 100 over 100. So the entire price of the jacket is 100%. It's one whole. That's all of the money for the jacket. And I want to increase that by 22%. So I'm going to add 22%, which is 122%. And so now 122% as a decimal, if you divide that by 100, that's 1.22. I'm going to multiply that by the $80. And if you plug that into your calculator, 1.22 times 80, the value you get is 97.6. $97.60. You see that I get the same thing. The difference is this. Before, I found the percentage increase of the price and then added that percentage on as a dollar value. In the second instance, I added the percentage as a percentage and then multiplied to get the dollar value. I'm doing the same two steps, but I'm changing the order in which I do them by adding the percentage first before I convert it to a decimal, okay? And see, hopefully you can see the advantage of this is it's a lot easier to do on a calculator in one step. Think about being at the store. If you were at the store and you were trying to figure out a percent, a discount of some kind, would it make a lot of sense to find this value and have to write it down and then add it to this? It's two steps on the calculator. But in this instance, you can do this part in your head, and then all you have to plug into your phone calculator is this guy, okay? Again, either one is fine, so whichever way makes the most sense to you, that's the way you should do it. I'm going to do it twice for each of these, all right? So if I look at this one, it says a $450 phone is on sale for 46% off. So now I'm decreasing the price. It's a discount. What's the new price? So if we're doing it kind of the way that takes maybe a little bit more effort, I'm going to say, hey, let's find the 46% off. So 46% would be 0.46 times the 450. And so once again, I plug that into my calculator, 0.46 times the 450. That gives me $207. That's not the new price of the phone. That's the discount that I'm getting. And so if that's the discounted price, I need to subtract that from the 450. Okay? And so again, the mistake that students make is they write that 207 down as the new price, when in fact the new price is $243. Okay? When I find that 46%, that's the amount of dollars I'm getting off of the price. Okay? Again, the other option is to say, hey, this started at 100% of the value. That 450 represents the entire one whole of the value. And I want to take away 46% from that 100%. See, I'm talking about percentages right now. And if I subtract that, that means I'm down to 54%. So now 54% is 0.54 times the original price of the phone is $450. And ready? 0.54 times the 450, $243. Again, part of that could be done in your head. And so this is a better way to do it in an actual situation where you're trying to figure something out at the store. Okay? Again, either one is fine. You just have to understand we're taking away 46%. So either take that 46% away from 100% and figure out what percentage you're paying, or you find the percentage off in terms of dollars and then subtract it from your price. Okay? A $299.99 multi-viewer is on sale for 36% off. A multi-viewer, by the way, is something that takes multiple like HDMI inputs and splits your screen. So like you could play a PlayStation, Xbox, and watch a movie all at the same time, all right, on one screen. But anyway, that's what a multi-viewer is. So it's a technology kind of thing. So it's on sale for 36% off. What is the price you pay after tax? So now we're going to have a couple steps in here. So again, if I'm doing it the way where I'm finding the 36% in terms of a dollar amount, I say, okay, 36% is 0.36 times the $299.99. And again, that's a job for my calculator. So it gives me $107. 0.996 that's the amount that I'm subtracting from the original price. So now I do the 299, sorry, I wrote a 7. So 299.99 minus that discounted amount. And notice I'm not bothering to round this thing off until closer to the end, and that's okay. So the 299.99 minus that guy is a 191.9936. And the reason I want to round it off yet is because when this is done at the store, a computer is doing this, so it doesn't round it off until the end. Of course, at the end, we'll round it to 2 decimal places. But now I have to include sales tax. If you don't know this, sales tax is 6% of the price. So if I'm doing it this old school way, what I have to do is I have to say, okay, I have to find 6% of that. 6% as a decimal is 0.06 times the 191.9936. Again, that's a job for my calculator. So I get $11.519616. But now here's the thing, that is not the amount I'm going to pay. That's just how much I pay in tax. So what I have to do is I actually have to add these two values together. Okay? And when I add those two values together, what I pay plus the sales tax, I'm plugging into my calculator here, I get and this is where I'm going to round off because I'm finally done. I get $203.51. Okay? And so there was a lot that happened there, and I kind of crammed it into a very small amount of space. Now let's see it the other way. Ready? So if I'm getting 36% off, let's think about that for a second. So I say, okay, 100. Let me write in this little nook over here. So 100% minus 36%. So basically, I'm figuring out the percentage I'm going to pay. That's 64%. So now 64% of that thing, so 0.64 times the the 299.99. That's now going to give me that $191.99.36. Again, I'm not going to bother rounding it off. But now I'm still one step away. I have to add the sales tax. Again, see that $191.99 is now like my total value. So that's my whole value. So that now represents the 100%. And I want to add 6% sales tax. So I want to do 100% plus the 6%. So I'm actually going to pay 106%. And watch this. As a decimal, that's 1.06 times the 191.996. And that's going to give me the 203.51. Okay? It gives me the same value with technically a lot less work, because here's the thing. Most of us can probably get by without showing any of this stuff right here. Okay? And so it looked like maybe it was close to the same amount of work until we think, do I really need to write down 100 plus 6 to get 106%? No. And so most people, when they calculate sales tax, they just always multiply by 1.06. It's the fastest and easiest way to do it. Okay? Let's do another one. Ready? A pair of headphones are on sale for 30% off of the sale. If the sale price is $55.99, what was the original price? Okay, so now this is working backwards. So again, this is kind of like what we did on the other page. If I wanted to find 30% off, and so again, we're going to go to the method I was doing before. So if something is 30% off, so 100 minus the 30%, you see that that's 70% of the price, okay? And so in other words, I don't know what the original price is. The original price we're going to call X, okay? That's what it started off as. So if I wanted to get a 70% discount, a 30% discount, it would be 70% times the X equals the $55.99. And now I can solve by dividing each side by the 0.70, okay? You can do it the other way, but it is a lot more work. I'll show you how to set that up in a second here. Again, this is a job for my calculator, the $55.99 divided by the 0.7. That gives me a $79.99. So the original price was $79.99 before I got that 30% off, okay? If you were going to do this the other way, here's what you have to do. It's kind of a mess here, but you have to think about it this way. You have to think about the original price, which you don't know, which is X, and then subtracting 30% of the original price, which is 30% of X, and then say that that equals 55.99. And so the setup is a little bit more difficult, but watch this. After the first step, you combine like terms. See, that's 0.7x equals the 55.99. And so we're doing the same thing divided by the 0.7, all right? I'm just cutting out that first step by thinking about subtracting it as percentages first, okay? If I look at this guy, company uses a 20% markup on all of their merchandise. If an item sells for $22.59, what was the original price? So this time it was a 20% markup. Again, I'm going to say, hey, instead of 100% of the price, we're going to add 20% to it. So my new percent is 120%. So now as I set this up, 120% is 1.2 times the original price, which I don't know, equals the 22.59. And now I can solve for the original price by undoing that multiplication. Divide each side by the 1.2. Okay. I like doing it this way because it kind of goes back to thinking about how we solve equations, all right? And think of everything in terms of an equation. It's going to make us better when it comes to equations. So the original price, the company bought this thing for $18.83, and then they increased the price to $22.59 so they could make a profit, okay? Once again, if you were going the other route here, instead of subtracting that and get the 120% first, you would have to do this. You'd have to say, okay, I have to take the original price plus 20% of the original price, so 0.2 times x, and then say that equals the 22.59. And once again, after the first step, right here, when I combine like terms, that's 1.2x equals the 22.59, and now I can solve the same way. Okay, I think it's easier, instead of adding those decimals, to add the percentages first and then write it as a decimal. Okay, but again, when you're thinking about percentages, think of them in terms of fractions. Understand that a percent means a fraction also means a decimal. These are all the same thing, all right? And so think about it that way as you start to multiply these things out and find percentages of values. Okay?